Welcome to Jerusalem, home to some of the most aggressive and impatient drivers on the planet, and home to Mobileye, a company acquired by Intel last year for $15 billion. The company's already made some 27 million cars safer with its adaptive safety systems, and now all those cars are helping to make this. It's the company's first fully autonomous car, and we're going for a ride.
So here we will activate the system.
And so here we can see basically the camera that's looking forward, which is kind of the main interface for the car. We've got bounding boxes defining all the traffic, everything else around us.
What you see here is gathering from all the cameras around the car, and making it a 3D view.
The car has 12 cameras in all, 3 that look forward at various levels of zoom, 1 that looks rearward, 2 on each side looking forward and backward diagonally, plus 4 more close-range cameras, 1 on each side, that are used primarily for self-parking. And that's it. There's no radar and no LiDAR.
Now we are merging. There are 4 lanes here that merge into 2.
Okay.
It's pretty tricky. Now we must be assertive here, otherwise we will be stuck.
Going about 45 miles an hour now.
We know the speed limit based on traffic signs and also based on our map, the RAM map. So we know how human drivers are driving here. And this gives us a very good idea of what is the allowed speed, but what is the actual speed.
Now we're going through a tunnel, which means things are a little bit darker. Does that make things more complicated for a camera-based system?
Yeah, and also note that there is no GPS here. And we are still localized perfectly on the map.
Interesting, okay.
Because we have landmarks, visual landmarks, that helps us to localize even without the GPS.
And are you reading the odometer from the car as well to help in this case, or is it just landmarks?
It's just landmarks now.
Really? Okay.
It's a tunnel. There is no other signals here.
And now this route, even though it's pre-programmed, has the car been told anything about this route, or is there any special care for this route?
There's nothing special about this route in the driving policy. We intentionally make it scalable by not doing any tweaks or tricks solely for this route. So we accelerated a little bit. You may wonder why. The reason, and then we brake. Now
this guy's not going to let you in.
And we will push our way. Okay?
That's pretty aggressive.
The thing is that we have a right balance between being aggressive and being safe. So we make this push like this, and then we sense he didn't let us go. Okay? So we let him go, but the initial push signaled to other drivers that we want to go. And then we will find the right moment to go.
And will the car cater its aggression to where you're driving? Will it read the aggression of other drivers too?
Yes, so we make the driving policy parameterized, and then you can pick what driver you want for any part of the world. Maybe you will choose a milder driver in California, a more aggressive one in Boston.
Yeah, Massachusetts was exactly what I was going to say. So this can handle the mass hole driver. It can also handle maybe someone from New Hampshire or someone from Connecticut that's driving a little bit more relaxed. So I noticed we're not, or taking this truck, we're going a little bit slower. Why is that?
So when we approach a highway exit, we do not want to take an unnecessary risk and perform a lane change, and then we will need to go back, maybe in dense traffic.
Okay.
So we do assertive lane changes only when it is necessary.
Okay.
Now we need again to make a change of lane in order to go back to Mobileye. So we are waiting for the right moment, and now we accelerate. The reason we accelerated because otherwise the car behind us would not let us fit.
I see.
Okay, so again, it's the communication without words.
And how much of the processing and how much of the logic involved is just to deal with the uncertainty of humanity?
Part of the strengths of our system is RSS, because if you can explain many phenomena based on few rules, then it generalizes to many crazy behaviors. And we saw it yesterday when someone backed up. We simply stop, and then we perform a change of lane and continue.
So basically providing boundaries between what is normal, what is aggressive, and then what is unsafe effectively, and then allowing the car to operate within that range.
Exactly.
When Shai says RSS, he's not talking about really simple syndication. He's instead talking about the company's responsibility-sensitive safety definition. Think of it as something like Isaac Asimov's laws of robotics, but instead of 3 simple rules, it's instead a 22-page PDF that attempts to define allowable behavior for autonomous cars.
When you talk about autonomous driving, you want to be safe. And in order to be safe, you want that to have redundant systems. And if you fuse all the information of radars and lidars in the low level, then you're not sure that you really have true redundancy. When I show you that the car drives itself completely based on cameras and completely based on radars and lidars, then you really get redundancy, and then you can be more sure about the safety of the system.
So when we get to a full production version of this car, it would have an additional radar and lidar system, but the car would effectively be able to drive itself on one or the other. So if one of them happened to be shut down totally, you'd still be fine?
Yes.
Wow, that's impressive.
Now, here I will take control. You will see that I will hit the brake, and then the system is off.
That was a little bit scary at times, as rides in autonomous cars these days can be, but honestly, that the car drives in an aggressive way was weirdly reassuring. It's also really interesting that the car relies only on optical sensors on cameras that cost just about $10 each. That makes this system much, much cheaper than the systems from other companies. And even when this does get laser and radar scanners added on, it'll still be far more affordable, which could give Mobileye and Intel a drastic edge in the autonomy race.